Copy the web app domain, add to scope in Burp. Refresh the page. We can see the request and response in Burp's HTTP History tab. We try to submit any random credentials, and this returns us with an invalid username error. This behavior reveals that the app discloses the validity of usernames, creating a potential username enumeration vector that could be exploited through brute force attempts. We will use this username Wordlist for our username brute force attack. Let's send this request to the Burp Intruder tab for brute force attack. And add the position that we want to inject the payload. Add our username Wordlist as the payload here. We will use grep match to look for the error message in each response. If any response does not show such error message, it might have a high chance to be a valid username if it's 200 status code. We start the attack. Let's wait for it to complete first. The brute force attack is completed. Let's filter on the error message. We notice username AU does not have this error message in its response, and its 200 status code. Nice, we found a valid username. Let's update it to our brute force request, and change the brute force area to password instead. We will use this password Wordlist for our password brute force attack. Replace the username Wordlist with the password Wordlist. Next, we test using a valid username with an incorrect password. The app responds with an incorrect password message, confirming that the username exists. This also tells us we can leverage it to enumerate passwords. Let's use grep match to look for this error message in each response when we brute force for the password. The brute force attack is completed. We found the valid password with a 302 status code. A 302 status code is a strong indicator of a valid password because many applications redirect the user after a successful login. Let's try login with the valid credentials we found.